So here they're saying in the diagram, O is the center of a circle, and then OM bisects AB. They mean which AM is equaling to MB, so it's given. And then they say prove the theorem that states that a line drawn from the center of a circle that bisects a chord is perpendicular to the chord. Any line which is drawn from the center of the circle and then it bisects the chord. They want us to prove which this thing here is going to be 90 degrees. And then how do you prove that then? You are going to tell them, which, okay, we are going to join OA and we are also going to join OB. So this is what we're going to do. We're going to do a construction here. And then we're also going to do this other construction. And then from here, we have two triangles. What are the triangles that we have here? Yeah, we don't have two triangles, but the ones that we're going to use is AOM again, and then triangle BMO. So we'll tell them within triangle AMO and triangle MBMO. So we're going to concentrate on these two triangles. If you concentrate on these two triangles, this is what we're going to see then. We can tell them which, like, I get OM, you see OM, okay? OM. OM, if you look at OM here, OM is something that appears on this triangle and then it also appears on this triangle. So it means, in other words, you can tell them which OM is going to be equaling to OM. They will want us to tell them a reason. Why am I saying which OM is equaling to OM? Why? I get this triangle AOM has OM again. And then triangle MBMO also has OM. Then I can say it's because it's common. Yeah, OM is going to be equal to OM because it's common. Okay. Now at the other instance, you can also say AO is equaling to BO. Why am I saying that AO is equaling to BO? Why are they equal? Eh? Yeah, it's because they are radius again. So you can say which OA is going to be equaling to OB is because these ones, they are radii, because they're equal radius. And then the last one, I am going to tell them which AM is equaling to MB or BM. Why am I saying this one? Why am I saying that this one is equaling to this one? Yeah, yeah, they're equal, but why am I saying they're equal? This part and then this part, they are equal. Why am I saying that? Yeah, we are given. We are told which these two things here are equal. So we'll say which this one here it's given. Then it means which we can look at this two triangle AMO and triangle BMO. We can say which triangle AMO is congruent to triangle BMO. Why am I saying which these two things are congruent? How did you prove our congruence? What did we use? We use a side, and then we also use what? A side. And then what else did we use? We also use what? A side. So we'll tell them with these two things are congruent because we use a side, and a side. And then from here onwards, it means, in other words, we can then say, but if these two triangles are congruent, it means which they are equal in shape and size. Okay? If they're equal in shape and size, then it means which angle A is equal to angle B, angle M is equal to angle M, and angle O is going to be equal to angle O. And then it means which Tina will come and tell them, which, okay, let's call this one M1 and then let's call this one M2. Or if you don't want to do it that way, we can call it this way. We can say OMA. Yo. So we'll say angle OMA is equal to angle OMB, which is this triangle. So OMB is this angle here. These two, they're equal again. Why are these two equal is because these two triangles are congruent to each other. For the fact that these two triangles are congruent to each other, it makes these two to be equal. Then we'll tell them which is because we have triangle AMO, which is congruent to triangle BMO. Okay, if these two are equal, again, this one and this one, they're equal. If they're equal, but remember, we can also tell them with Amara, remember, AMB is a straight line. AMB, it's a straight line. Now, if this thing is a straight line, what does that mean to us then? What can you tell me about angles on a straight line? They add up to 108 here. Then it means which you can tell them which, okay, but now M1 is going to be equaling to M2, which is going to be equaling to 90 again. It's because we know which there are adjacent angles on a straight line. Yeah, they're angles on a straight line, yeah. They're angles on a straight line. Therefore, it means which we have proven which the line bisects, because again we've proven with this one is 90, and then also proven with this one here it's what it's 90. And then a question like this one, again, you saw it's 6 marks. So how would they give you a 6 marks? So you get 1 mark for construction, 1 mark for this one, 1 mark for this one, 1 mark for this one, 1 mark for this one. So you have 1, 2, 3, 4, 5, and then you have 6. All in all, you're going to get you 6 marks.